Hello and welcome to another Developer Essentials. So this time around, we're going to be taking a look at working with random numbers. Now, random numbers are something where they're such an integral part of so many games, but it's something where if we just throw in random, we know that it can easily be very chaotic and messy. So we want to kind of understand, how does random work and how can we actually control it and how can we use it in a way where it's enhancing our game, where it's enhancing the experience for the players and not just creating a chaotic, frustrating mess. That's going to be the goal. Okay, so let's dive on in. So what I've already set up here is a couple of different things. So I've got a couple of scenes for looking at a few different areas for this. So one of the first ones is I've set up this grid spawner. And the reason I've done this is this spawns a grid. The grid is just a bunch of prefabs, and you can see at the moment they're all the same height, but we do have some stuff for configuring what the min and max height is. And so the reason I've gone for this one is this is a really great way to illustrate one of the actual problems with just pure random. So at the moment, I'm spawning the grid cells. So if I wanted to bring that height in, I can do that quite easily because the way I've authored these prefabs means I can just actually change their transform. So new cell, it's transform, and it's a local scale. I can say that that's a new vector 3, 1, a random range between min height and max height, and then 1. So this, we're kind of expecting this to be pretty chaotic, and this is a really good way of illustrating one of the key problems with just using random directly and why we often need to do extra stuff with it. Because you can imagine, if this was a terrain, this would be challenging to navigate, to say the least. So this is not really going to work for something where we're trying to navigate. It's far too chaotic a set of changes. There's not any smooth, gradual changes there between them. So oftentimes when we're talking about using random, potentially what we're more talking about is actually using something called noise. So noise patterns often will have ones that they can get a very smooth generation, a smooth change between things, which is going to work well for something like a terrain, for example. So what I could be doing for that, so pure random is very chaotic, not ideal for a walkable terrain. Noise is a better option. So we have mathf Perlin Noise. Now, Perlin Noise takes in an X and a Y coordinate. So, okay, well, let's just chuck that in, our column and our row, and that's going to, it gives us a 0 to 1 value. So, height percentage. To calculate that, so then we can easily set our scale, because what we'll be able to use is we can just do a lerp. So vector 3, 1, mathf lerp from my min height to my max based on that height percentage. Now this, if I just use this, it's actually not going to work properly. And it's not going to work properly for a reason we'll be fixing in just a moment, but it's good to illustrate this because this is something where if you dive in with Perlin Noise, this is a problem you'll very easily run into, where everything is the same and it's all at the height of 1. So Perlin Noise loops. And in particular, if we provide an integer value in here for the row and column, the value we get out will always be 0. So we have to provide non-integer values here. So what we would often have is something where let's set up a vector 2 height noise scale. And let's pick some suitable values. We want this to be so that these are turning into something that's under that 0 to 1 range. So it's within that rather than being something that's going over that. So I'm going to make this 128, and then here I would do column divided by height noise scale.x, row divided by height noise scale.y. That should give us a bit more in the way of variation there that's happening. And what we're looking for is, with Perlin noise, we should see a smooth variation between stuff. And we can, it's very, very subtle, but there is some variations that are happening here, but it's happening over a really long sort of range. So we need to have a bit more scaling happening here. So we know we've got our row and column divided by that. Let's try dividing this by a larger value. So let's ramp this up to 512. And it's good to experiment with changing through a range of different values here. So, okay, we've got that working there, and we can see they're all tending to come out at fairly similar sort of size. So that means we're tending to get fairly similar values here for our height percentages. So we can check and make sure that with this we're using our row and column, which is fine. With our height and noise scale, we can try going for a lower value. So we've tried higher. Let's try something like 32. And so there we see a much better variation. And the key thing that we can see is with this, we get smooth changes throughout. So even though we're using something that's a very blocky shape, we're using something that's a really, really sharp edges, we're actually getting quite smooth changes with this, which is what we would expect. That's the advantage with Perlin noise. You get those smooth, gradual changes. And if we drop this a little bit further, then we will see that will change the features. So a lower value is giving us more features in here, whereas a high value is going to give us larger features. So they'll span over larger. And that's why when we use like a 512, we weren't seeing really any variation. It's because the features were so large, they were taking up the entire space. But this is something that a character could actually quite comfortably navigate. The level of step between these areas is actually quite small. So that looks pretty good. But okay, well, we're using noise. What if we want a bit more variation to it? That's where a little bit of randomness on top of this can actually be beneficial. So we could have something where, so random noise, and we're going to make this really quite small. So a really small amount of random noise. Because what I could then do is, okay, well, that height percentage, let's vary that a little bit. Let's vary that a small amount. And what I could say is, let's vary that by random range minus of random noise to random noise. If I do 1 plus, because what that will do is that will give us a random value. In this case, it would be between, and I might make that a little bit larger, be between 0.95 and 1.05. So it's going to scale down or scale up that height percentage a little bit. So this will just break up the features a bit. And that's where randomness can be quite helpful in things like terrain generation, is as a tool for sort of breaking up features. So let's run this and let's see how this looks. That might be too large a value. Actually, no, that looks all right. But we can see that's taken, we'd see more smoother changes before. It's just sort of made it a little bit noisier, which is actually a really nice sort of effect. It breaks it up a little bit more, and the end result is it actually feels a little bit more organic because there's that extra sort of messiness to it. So if we're wanting smooth changes, a noise function is a better option, but we can then layer a little bit of randomness on top of it to improve the result that we get there for it, and to make it look a little bit more organic, a little bit messier. And we can go a step further because I have the cell mesh being retrieved here. So what I could also do is randomize the color just a little bit. So not a huge amount of change, but just a little bit of a change for it. So it's cell color. So what I would do is, this would be a case where I'd typically use something like a material property block. Property block is a new one. The property block, I can set the color, which the color is usually just going to be _color for the standard shader. Gradients, we evaluate and we provide a 0 to 1 value. So I can give it a random range 0 to 1. And then what I can also do is then apply that. So cell mesh, set property block, so it looks pretty good. And then what I would do is I would adjust on that prefab for it. I can adjust the actual color range here in the gradient. So we can start it at a sort of darkish green. And we're going to get rid of that because we don't want any transparency with this. It's just going to be the full color. And then this can be a bit of a lighter shade of green. That looks pretty good. Just enough so that there's a little bit of color variation that's happening there. And then we can see that's coming in and that's applying some color changes to it. Again, we could also connect this in with the Perlin Noise a little bit so that there's a bit more consistency to the patterns. That would be something that we could do. But I think in a case like this, that looks quite nice with it sort of randomly varying it. So, okay, that's cool. That's one thing we can be doing with random. We can use noise for smooth changes and use random for causing a little bit of sort of interesting variation to make it a bit more organic. What about when we're actually picking things for spawning? So at the moment, I have set up this cube stacker. And what the cube stacker does is kind of what it says on the tin. It currently spawns 50 cubes and they're all the same prefab. So let's set this up so it's actually able to spawn all of our different types of cubes. And I'm going to do something that initially might seem a little bit over-engineering, where what I'm going to do is I'm going to set up a class here. So spawn config. So initially this is going to seem like this is absolutely overkill, where I have all this spawn config, which all it's storing is a prefab, but there is a reason for this. Spawn configs. So then I'm going to pick a random config. So spawn config, spawn configs, random, range from 0 to spawn configs count. And then we spawn that particular prefab. So although this initially does look like, yep, this is massively over-engineered because I'm just storing these prefabs, there is a reason for this. Because we're going to set this up initially where it is just fully random in terms of what it spawns. Then we want to set it up so it is a weighted random, so that we can control what proportion of the ones that are randomly spawned are particular types of ones. So let's just link up all of these, and we'll then spawn this setup. So that looks good. So this is pure random, so there's no balancing, no control over what ones are actually spawning. Which, say this was loot in a game, this is the equivalent currently of every item has equal weighting, which is not really what we want. We want to actually be able to control the weighting of stuff. So, okay, weighting. Now, this weighting, there's different ways we could set this up. So ideally we want those weightings to add up to the same, to 1, or at least to a consistent value that we know. But that means then when I change this, I would need to change these other ones, which we can absolutely set up UI to do that. We can set up custom inspectors that will make that happen. The other option that we've got is we just let people use whatever values they want here, and then we normalize them in-game. So normalizing meaning we reduce them to that 0 to 1 range. So I'm going to go for that approach. So I want there to be, let's make it that blue has a 15% chance. So I'm going to make these roughly add up to 100. I'm going to make cyan be less common. So it's going to be 10, so we've used up 25. I'm going to make green be very frequent, so let's go for 50. So we've used up 75. I'm going to make magenta 5, and red 10, yellow 10. So these are the rough percentages, so what I want to see is a lot of green, and then smaller amounts of the others should see roughly similar proportions of cyan and red and yellow, a little bit more blue than those, and a little bit less magenta than those. So that gives me my probabilities, but I need to normalize them, and I need to work out how to actually be picking from those. So I'm going to look at a couple of ways of doing this. So I'm going to set up a function here, spawn stack method 1. And actually, I'll set up a couple of methods. So method 1 is pure random. Then we're going to set up spawn stack method 2. And this will be weighted random. And this is the one I'm going to hook up here that will actually be running. So spawn stack method 2. So this needs to pick out a particular one randomly here. So first thing we typically would need to do in a case like this is normalize the probabilities. So what I can do, and there are a lot of different ways of actually doing this. So first thing, I need the sum of all the probabilities. So sum, we have to loop through all of the probabilities, all of those spawn configs, config in spawn configs, sum config.weighting. So we work out the total weighting. So to then normalize those, we loop through again, spawn configs, and then I can go config.weighting divided by sum. Now we can get away with doing this, even though we're modifying something that we've got is configured. It's not going to persist that, because this is a change that will happen in the editor. We could store these normalized weightings elsewhere as a way of just ensuring that, which that's what I'm going to do instead. Normalized weightings just because it's not really great practice to be modifying those existing ones. We're one bug away from it accidentally modifying data. So in this case, we'll just put it into these normalized weightings. So those normalized weightings will now add up to 1, which is good. We then need to work out, well, okay, we've got these things, they add up to 1. How do we work out which one we pick? So what we can do is we can actually be keeping track of our weighting offset. So we divide these into buckets. So weighting offset is equal to 0. And what we do here is we add in weighting offset plus this value. So for the first one, it'll just be that normalized weighting. For the second one, it's going to be whatever we added in just before. So this I'm going to put into another variable, normalized weighting. So calculate the normalized weighting, we store it, and then our offset, we add that to it. What that will mean is our first value will be just at 0. Our second one will be its normalized amount plus whatever had come before it. So we have something we can then compare against. So we calculate the sum of the probabilities here. Probability sum, and then here, calculate the weighting buckets. Now here, in terms of how we actually pick the things. So spawn box. So first we roll a random number. So our random roll, and this is going to be a random range 0 to 1. So now we have a 0 to 1 value, and we also have a set of buckets that each bucket covers a particular range. And wherever our random roll sits in that, that corresponds to the config that we actually use. So what we would do is, firstly, we have a default of our spawn config is just going to be the first one. And then we loop through our spawn configs. So config index is equal to 1. Config index is less than our number of configs. We update that. And then what we do is we check if the weighting for this. So if our normalized weighting at that index, so this normalized weighting's there, that first one will be, for example, 0.1, then the next one might be 0.25. So if we rolled a 0.05, we'd pick the first bucket. If we rolled, a 0.25, we'd pick the next one. So what we're checking is if our random roll is less than it, then we can, that's the particular bucket that we actually can use. So if our random roll is less than it, then we can say spawn config is equal to spawn configs config index. Otherwise, we break. So we've hit a point where our random roll is above that. Now, we also need to check that it's not just that it's less than the current one, but that it's also greater than the previous, so we can narrow down that we're in a particular bucket. So, and random roll is greater than or equal to this minus 1. So roll is within the bucket. So find the corresponding spawn config. So this will give us the ability to control the proportion of things. Now, we can still go outside of those specific proportions. The exact results we get won't be perfect every time because we're still using randomness. We can still get streaks and things like that happening. But let's see how this works. So we can see this has given us a lot of blue box, a couple of cyan ones. So that's something where we want to take a look and see. I would start by, let's run it a couple of times, see if it's consistently doing that. And it looks like it is consistently doing that, which that suggests there's a problem with how it's actually generating these. So this is something where good to then go through and be debugging it. So we still have, unfortunately, the bug in VS Code where we need to go to an extension to then be able to actually set up the ability to debug our code. That's a useful way to work around that if you are running into that with VS Code. So let's run this up. So we'll check that it's normalizing the probabilities correctly first, because that's something that could go wrong. So a sum is 100. That looks correct. These weightings look good. So if it's less than, so 0 to 0.15 should mean that we pick the first one, 0.15 to 2.5. So those look good. Those buckets look correct. The random roll, so it's rolled a 0.18, so that should be between these two ones. So that should mean that it picks config 1. So we can check. So it's found the weighting, that's going to match to config 1, and then the next time it comes through, it should exit, so that's good. We can then check with a couple of other values, because we want to make sure that it's consistent. So this time we've rolled 0.88. So this is a good one where this, we would expect it to be 3 or 4. So we run through our random roll. We're checking, is it less than this? And is it greater than this? And if it is, so this is where we're hitting into an issue because we're breaking at that point. So that's where we need to clean up our logic a little bit, because we should only break in this case, because if our random roll is less than these, then we shouldn't actually be breaking at that point. So this is a case where we should only break if our random roll is greater than our normalized weightings at that index. So let's try this now. We should hopefully see more of a variation there with the ones. Run, so still getting it running and producing a lot of similar ones. So this is, actually, this was around the wrong way. This should only break in that case if it's less than it, because otherwise we need to keep going. Always easy to get less than and greater than mixed up. So we'll run with this. So we're now getting our variety of ones. We're seeing a lot of green, which is good. Now we're spawning 50 ones, so we would expect with 50 ones being spawned, maybe 2 to 3 magentas. We can see we've got 1, 2, 3, 4, 5, because we're not enforcing that there can only be that proportion. So we've got it still weighted, so we are seeing more green than the others, but we're still beholden to the fact that it's random. So this is an approach that is good if you're wanting to, for stuff like of loop generation, this can actually be a good approach in that it's random, it's not something where people can guarantee what they're going to get. Sometimes they'll get really good luck, sometimes they'll get bad luck. That is still a factor with this method. So this method is a weighted random, and still get streaks of good or bad luck. So it still gives us streaks of good or bad luck. There's a third method we can adopt, though, that actually eliminates streaks. So I'm going to start off with fairly similar to what we had before. So this is going to be method 3, fixed proportions. So I'm going to switch this over to method 3, because sometimes we want actually a very fixed amount of things, but what we're randomizing is where they appear. So we always want there to be a set amount of things, but the order that you get them in varies. So we can do that. How we go about doing that is, so we go through and we have worked out these particular weightings. We still normalize the ones. But then what we actually do is we don't have this list of normalized weightings. What we have is spawn config, configs to spawn, new list, that. So we've got a normalized weighting. What we actually calculate here is num for spawn, or num of this config. So we actually set up a fixed number of that config that will spawn. So this is going to be our normalized weighting. So we still grab all of that, because that's going to be a 0 to 1 value. But we multiply that by our total number to spawn. And then let's round that to the nearest integer. So this is the number of this config to spawn. Then what we do for count equals 0, count is less than num of this config, and then we add that into our configs to spawn. So we create that number of copies in there. What this does is we'll build up this configs to spawn. We'll have the exact proportions of the particular ones we need. We know we're spawning 50, so it will make sure that there are the exact right amount of each of the particular types in there. Then what we do here is we pick a random config index, random range 0 configs to spawn count. Then that is the config we use. So spawn config is configs to spawn at that index, and then we remove it so we can't pick it again. Remove at config index. So this means we will have fixed proportions of the particular things, but the order that they appear in will be randomized. So it's a different way of working with it. It's an ideal thing more for if you're spawning different sort of objects or resources, things like that in the world, where you want to randomize their location, but not the number of them. And we'll see with this, our number of magenta ones will actually always be consistent. It will be around that 2.5 to 3 value. Where they appear is going to change, but the number that appear is always going to be the same. So location is varying, but the number is always staying the same. So I'm going to set this up so we actually have different methods that we can use for this. Spawn method. So we're going to have pure random, weighted random, fixed proportions. Just so we can easily test different ways of doing this. So let's field. And we will default to pure random. And then just based upon the method, we'll just pick which one to actually use. Just lets us easily compare, because these do serve different purposes. You know, pure random is great for things where it's primarily just a visual effect, where it's something that it can be, varying proportions. You can get streaks of good and bad results is completely fine. Weighted random is great for more things like loot, where you want there to be still streaks, but you want things to be able to be more or less likely. And the proportions is great for spawning objects within the world, where we want to make sure that we have, for gameplay reasons, control over the number of ones that are present. So now we can just easily switch between these, which is handy. And then one of the things we're noticing with this, though, is every time we run, it's slightly different. So what we can actually do is we can seed our random number generator. Serialize field, random seed. So I'm going to put it as 0. And then we can say random init state, random seed. Because our random number generator, if we seed it with the same value, we will get the same result. So this is something that can be particularly important for things like multiplayer or being able to replay things that you might need to actually store the seed. So with it set to 0, we've got 2 green, 2 magenta, 2 green in the middle there. So we'll stop, we'll rerun again, and we should see the same results. 2 green, 2 magenta, 2 green. If I change the random seed to anything, really, I should see a variation there. So again, changes. So we've got the ability to seed our random number generator. It can be really handy to control what's actually happening there, because it allows us to set the random number generator to a fixed state so that we can control the behavior and what things are actually going forward there with it. So just recapping on a couple of the key things. In terms of with working with random, we can use pure random, where we're just rolling a random number, picking a particular thing. That's going to give us something that's very chaotic. There'll be streaks, there'll be no sort of consistency or evenness to it. Great for sort of visual effects or for things where it's not going to have a gameplay impact. If we are wanting to have a bit more control over it, we can have a weighted random, where we have different probabilities of something happening, but where it's still able to get streaks there. So we can get streaks of good luck and bad luck. Great for things like of loot, for spawning that. If we need really tight control over it, because it's for something that's very, very gameplay impacting, so we want to actually control the specific proportions. So we still want things to be random in terms of where or what things might be in different locations, but the number of each thing is fixed. Then we can use a process where we fix the amount of particular things and we spawn from that list. So that gives us a lot more control over it. And then finally, the other bit that we saw at the very beginning was working with using noise with a little bit of randomness layered on top to improve sort of the visuals there, to give us a bit more of an organic look to those visuals. Because as we saw with the terrain there, that gave us a much more sort of organic look to it, because we had some nice variation in terms of with the color, but also the height was changing not perfectly smoothly. We had a little bit more sort of choppiness to it, which worked out really quite nicely. So dive on in and experiment with the project. As with all of the projects, the full code is available up on GitHub. You can use that code for any of your own projects, whether those are commercial or non-commercial ones. It's fully free for you to be using there for it. If you found the video helpful, please do chuck in a like and subscribe. It really does help out. If you've got questions, throw in a comment below. And if you're looking for other ways for supporting the channel, I do have a Patreon, and the link for that is in the description below. Bye.